Hello, it's dumplet here. Here's an item on functional equations. Let f be a real valued function mapped from real to reals, such that f of x squared plus xy equals f of x times f of y plus y times f of x plus x times f of x plus y for all real numbers x and y. Now this question is from the Czech Polish Slovak Match 2018 and it is in problem 1, so it's relatively a simple item. So as usual, pause this video if you'd like to give this item a try. But if you're done, let us dive into the solution. Now in a Math Olympiad fashion, I'm going to put a claim, and I'll be claiming that there are 3 functions that satisfy. And I won't be spoiling what these are, but we'll get to know these 3 functions as we go along. Now, to solve these types of equations, usually we start by substituting simple values of x and y. Let's say x equals 0. Now, if I define x to be 0, I'll have the following. Now, this term just becomes f of 0, the first term. F of x squared plus xy just becomes f of 0. Next, equals, so f of 0 times f of y plus y f of 0 plus the last term, since there's an x here, it's just going to be 0. So we can rearrange the terms here, and since each term has a common factor of f of 0, we can actually factor it out. In fact, arranging the terms, I'll get that it can be factored into like this. So from these two, we can, since the left hand side is 0, we have 2 cases. First case, f of 0 is 0. Now the second case, this part equals 0, this second factor equals 0, and I'm going to get that f of y is equal to 1 minus y. And what's nice about this is that this is true for all real numbers y. So we have solution 1, and it is the function f of x equals 1 minus x. So that's function 1, and well, that's only one of the cases, so we still have to take care of the other case. So one case is done, so this case is done, so we have to check for this one. Now let's consider the case where f of 0 equals 0. Now, since we want to use the fact that f of 0 equals 0, let's make y equals negative x. Since it's going to make these two highlighted terms here, it's going to be f of 0. So, well, as mentioned, f of x squared plus xy, if y equals negative x, this is just 0. So I'm just going to put 0. So 0 equals f of x times, well, f of y becomes f of negative x. And this becomes minus x f of x. And then the last term, as mentioned, f of x plus y, it's just f of 0, so it's just going to be 0. So we'll have this. Now what's nice about this is that, just like the previous step, there is a common factor. In this case, there's a common factor of f of x, so I can factor f of x out. So f of x, I can factor it out, and what remains is just f of negative x minus x. Now what's nice about this is that, again, we have 2 factors, so f of x equals 0. And this, if I equate it to 0, I'll get that f of negative x equals x. Now, since this is true for all real values of x, I can write this as f of x equals negative x. So it's equivalent statement anyways. Now, technically we have 2 functions here, f of x equals 0 and f of x equals negative x, but we're not yet quite done, because all we've proven is that for every real number x, f of x is either 0 or negative x. But we can't really explicitly say that it is 0 for all real values of x and it is negative x for all real values of x. So here we have the case of a pointwise trap. So it might be a piecewise function. For example, some real values of x will give you 0, some real values of x would give you negative x. We're not really sure. So we have to take into consideration the fact that there might be some values equal to 0 and some values of x that is going to give 0 and some values of x that's going to give negative x. Now to deal with this, we will let variables here. So let's just take the variables a and b. Now we need to define our variables, in this case not equal to 0, because if a and b are both equal to 0, we don't really know is it corresponding to the 0 or to the negative x. Now this is just to make things clear, so we could easily differentiate whether it's taking the x or is it taking the negative x. Now, from this definition, we're assuming for now, so suppose there exists a and b that are non-zero, such that f of a equals negative a, f of a equals 0, and then f of b equals negative b. So we're assuming for now that there is some values of a, there's some value a such that it's equal to 0, and then there's a value of b such that it takes the negative x case, so it's negative b. Now we're going to try to substitute this into the original equation given. So we have these two, and we want to substitute it back. Now, I have here let x equals a, let y equals b minus a. So obviously, we want to incorporate these into the above equation. Now, these are just presets, so the motivation will be clear. And the motivation is to make these two terms be nice terms. In fact, f of x squared plus xy, if I do that for the case where x equals a and y equals b minus a, that's going to be equal to f of ab. And f of x plus y here is going to be b. So we can use the fact that f of b equals negative b. So we're trying to deal with the first case first. So f of ab equals, now f of x, f of y, since x equals a, then the f of x here becomes 0. So that's just 0. Same for this case. So we're just technically, this becomes 0, this becomes 0. So just x, f of x plus y. Now, since x is a, I'll write a here. And since x plus y here is a plus b minus a, it's b. So, and f of b is negative b. So f of ab is actually equal to negative ab. So no problems here so far. Well, ab here actually takes the negative x case. Since, as we've mentioned, for every real value of x, it's either 0 or negative x. Now, in this case, f of ab will take the negative ab case. Now, what's interesting is that if I let x equals b and y equals a minus b, now f of x squared plus xy, that's still ab, so f of ab equals, now f of x is f of b now, so it's going to be negative b. Now f of y is f of a minus b. Next, plus y f of x, so plus a minus b. Now f of x is b, so f of x is f of b, so it's going to be negative b. And then f of x plus y over here becomes a. So f of x plus y becomes f of a, which is 0. So we're just going to deal with this. Now, we can make the substitution here that f of ab is equal to ab. So, f of ab equals negative ab. So I'm going to write here negative ab. And then we can do some simplification. We can solve for f of a minus b here. Let me move a little bit. Now, if I solve for f of a minus b, what I will be getting is very interesting. f of a minus b, that's actually equal to, if you simplify these, you're going to get that f of b, negative b, f of a minus b. Well, this part is negative ab plus b squared. So the negative ab's will actually cancel here. So it's going to give me negative b squared on the other side. Now, since b is not equal to 0 from our definition, we'll have here that f of a minus b is equal to b. Now, we're going to only focus on this now. So let me just remove all of these. So let's focus on the fact that f of a minus b, this equals b. Now, we know that f of a minus b can take two values. It's either 0 or the other case where it's equal to the negative x, so negative of b minus a. So we have two possible values, negative of a minus b. Now, if we take the blue case, if f of a minus b equals 0, then 0 equals b. Contradiction. It doesn't work because we set that b is not equal to 0. Now, if I take the negative a minus b case, negative a minus b equals b. So let's do some simplification. It's going to become negative a plus b. This equals b. I can cancel the b's, and this is going to give me a equals 0. Again, another contradiction. So we started with the assumption that a and b, so we started with the assumption that there exist a and b. So suppose there was a and b such that f of a equals 0 and f of b equals negative b, and we ended up with a contradiction. So this means that our initial assumption here is wrong. So there aren't any values or any pairs a comma b such that f of a equals 0 and f of b equals negative b. So from this, we can finally conclude that we finally resolve the pointwise trap, and then it is indeed true that if I have this, it's going to be either for all real values of x, I would have f of x equals 0, and for all real values of x, I would have f of x equals negative x. So that resolves our pointwise trap, and we have two additional solutions, and then we're going to include the first one that we got, so we can finally conclude that this is the first one that we got. So f of x is equal to 1 minus x for all real values of x. And then from the pointwise trap, we resolve these two to individual cases. So it's either f of x is always equal to 0 or f of x is always equal to negative x. Now, this sign over here, it just tells you that it is always equal to, so we don't have the pointwise trap anywhere. So we have three solutions. We have three functions f that satisfy the functional equation, and these three will be our answer. So this is the final answer. Hope you guys liked the video. Hope you guys learned something new from this video, and I'll see you in the next Olympiad question. Bye bye.